Now, what you do is you're gonna loop on the text file. So while true, and you're gonna break this loop only if you arrive on a line that is null. On line 3, you can see if line null break. So if you are at the end of the file, then stop. Then here we just replace the quote symbol into nothing because you don't want to fit your algorithm to the quotes. And then you tokenize the line into 5 tokens, comma separated tokens. So if you are in front of a file that has tab separation or anything, you can change here this little argument here. If for some reason the length of the tokens is different from 5, we have no idea what is this line and it's not in the standard format, so you want to skip it. Now, you have the category, which is string category. It's a new string, and in this category object, you're going to put negative smiley or positive smiley. That's just what we decided. So if your first token, which is, as you remember, the sentiment, is equal to 0, then we know that the category is negative. If the first token is 4, the category is positive. So you create this one, you're on a specific line. So you do that, you get the category, then you have the ID, which is the second token, the message, which is the 5th token. Then you're going to say, okay, my key is /category/ID. That's how you design a key in a sequence file. Then the message, the value is going to be the message, and writer.append, so you add to this writer the key value, and then you increment the line basically. You increment the count of the line, and at the end you close your writer, so it's going to automatically create the sequence file and save it, and then you system out print, okay, I wrote as many entries, okay? And that's basically it, and that's very flexible because you can change the tokenization, how many separation there are, which one is going where. So it's very flexible and it's very easy to implement once you have a first model, which you do have now in my folder. Now, if we're talking about the test part, because that was the training part, the test part has topic, sentiment, tweet ID, tweet date, and tweet text. So you see that it's a little bit different. Here you see that the first, the token ones, which is the second token, sentiment, we said, okay, if it's negative this time, because that's how they choose to do it, they put negative or positive as a word, we say, okay, it belongs to this category, negative, smiley, bad faces, which is our category. And then the same for positive, and if there's any other categories, and there are neutral, irrelevant, and some others, you don't want to take those lines because your training set can only identify negative and positive. So you discard those lines and you can just show skip line. Okay, and then the rest is pretty straightforward, is as usual. ID, message, you set the key, set the value, add the key value to the writer, increase the count, close the writer. And that's it, you know. And I think it's a good exercise to do because I think TXT and CSV files are pretty common as a format, so it's nice to have this under your belt. Now you want to transform the text files into the sequence file. This is really a transformation that implies a specific format for Hadoop so that it can treat it. So you're gonna call the jar, Hadoop jar. So first of all, obviously you need to create the Java project and put those two into a package, export it as a jar. So that's not something we presented into the presentation because we all know how to do that. But if you do want to know, in the demo working code, you have all the steps necessary to create a jar and everything. So you create this jar, you call it to Hadoop jar, call the jar, and then you remember that it has 2 arguments. The first argument is so obviously you call the class first of all. So Mahout that tweet2sec. Mahout is our package. Tweet2sec is our class. Then the first argument is the input, and the second argument is the output. The input, final assignment, train CSV. So you do have to have a local file, train CSV, that is into final assignment locally, and then final assignment train dash sec, which is going to be saying that, okay, you save this under that, and because you're calling Hadoop jar, it's going to save it under the HDFS final summon train sec. So that's why you have to create the folder beforehand. I'm sorry. Then you do the same for the testing sample. So Hadoop jar is the same jar. Now you call the class tweet2sec_test, which is the second class, and then you have the input test text file and the final summon here. You can see that if you call that, you're gonna get something like wrote 1,600,000 entries, which is what we designed it for. So you're happy, you have your sequence files, and from there you don't need to be playing around Java anymore. You're just playing with Mahout command lines, which are the one you saw before. So you train them all, sec2sparse. My input is my training sequence, and my output is the sequence vector, log normalization, new name vector, and the weight you want TF-IDF. So obviously TF-IDF is term frequency, inverse document frequency, which we talked about. It's pretty common in sentiment analysis to use that. It's recommended actually to use that. So we're going to be using that. And then you call the training naive Bayes algorithm, and you say, okay, well, here's my vector. It's TF-IDF vector that we just created here. And then the output is going to be the model. And the model is really what we're interested in. We're going to use this model and apply it to the testing set. Okay, so you see that it's a pretty the sec2sparse took like 19 minutes. So you are in front of something that has a lot of data, and you're starting to have material time to compute everything. Step 6, you want to test the model. Okay, to test the model, you first need to transform your sequence vector into your sparse vector. So your sparse vectors, as a reminder, is really into the space. You have these multi-dimension vectors with all this bag of words and all the weights. And those are really the vectors you want to have to test your model. So you transform into the sparse vector, sec2sparse. So this time you take the test sequence and you're going to output into the sequence vector, log normalization, name vector, and the weight using TF-IDF again. And then Mahout test NB, so naive based, test vector, TF-IDF vectors, and then the model, label index, and then this. So you can see here, the correctly classified instance is 54.12%. It's really low. It's really low because we have two categories. So statistically speaking, 50-50 percentages of accuracy would be pure luck. So it's very low, and we're going to discuss the pros and cons. And that's going to be our last slide. The pros, obviously, it's pretty obvious that it's a way to automatically construct the training set. You do know how costly it can be to have a training set, and that can be a very nice way of doing so. You have no language barrier. I mean, the smiley faces are international. Everybody uses them in the same manner. The pros, not on the training set part, but on the algorithm part, the naive Bayes algorithm is a very simple algorithm, so it's very nice because it's very transparent to understand, and it's pretty simple to implement, and it's quite fast. The cons, the smileys do not give you a neutral state. I mean, you could think of stuff like, okay, if I have a bad faces and then a happy face, that would be a neutral state, but it's probably going to be very spurious, so you don't want to use that. There's no way to have the intensity. Indeed, I mean, you could say, okay, well, if I have several smileys of the same faces, that's a high intensity. But that's really more specific to the individual. Some individuals are always going to use a whole bunch of smileys, and others are not, so it's probably not significant, so you don't want to use that. one of the most important cons is really the smileys are used by a specific part of the population, mainly the young people. So they're using specific vocabulary, abbreviation more often into Twitters, and they're applying it to specific topics. So you can say, okay, if I train my sample using the smileys and I want to test what is the European Central Bank policy flavor on Twitter using this, you're probably going to have bad results just because you are not capturing specific bag of words that could be linked to this topic, just because your training set could not, due to the fact that the young people do not talk about this or do not use smileys into these topics. So that's an issue. It cannot capture sarcasm. That's an issue that you have with this methodology of the training set, but that's not an issue in general into the sentiment analysis. The sarcasm is very hard to get. Multiple ID issue. If you have something like, hey, my Harvard is better than Berkeley, it's my happy face. Well, the happy face is going to say, okay, it's a positive tweet, and Harvard and Berkeley are going to have two positive notes on them. But actually, it was more on Harvard to have the positive and Berkeley to have the negative, or something like this. So the multiple ID is an issue. And in the case of the smileys, most of the tweets that have multiple IDs that would have multiple smileys are going to be deleted. So keep that in mind. And the cons on the algorithm part is really that the naive Bayes algorithm is a pretty simple one, and you probably could get better results with other algorithm like a neural network or something like this. So as a conclusion, I think this methodology is a great idea. It's still not yet powerful enough, at least in our context and in our test. There are some studies that are starting to use all the emojis, so you know, all the different pictures that you have available on your phone, and to try to get those emojis to get a broader spectrum of IDs and of sentiment in general. So we're getting towards this, and I think it's really important to try to go find solution of this training set, because as of today, the training set are really hard to get, and it's really the bottleneck of the process is there. So I think it's a good it's good practice to start thinking about this. And well, for the rest, I mean, the implementation of the algorithm was pretty straightforward. I think it's a powerful algorithm, but I think the training set was not good enough to predict that. And that's it on my side. Thank you for listening to me.